Now you can see. Okay, good. Okay, no worries. Sometimes these things happen. Okay, I will quickly brief and Mhm. Okay, sure, sure. I will upload those. No worries. Yeah. In the Google Drive, I thought they were already there. Okay, okay, fine. I think I might have put it somewhere. Okay, I will upload those. No worries. But anyway, so if you want to have recordings, no, you can directly go to YouTube channel. Everything is there here. So if you notice, all your machine learning, linear regression, everything that we have talked so far is already here. I will give you the direct link on the chat. You can refer just in case. Okay. So I have given you on the chat. So everything is there on YouTube as well. Okay. All right. So coming back to logistic regression. So we have yesterday discussed the intuition part, how the solvers are being used and how linear regression is being used. Once you find out the m values, then you use sigmoid function to make the straight line into S-shaped line, and then you use a threshold to classify the various classes, two different classes for binary problems. Okay. So this is the sigmoid function, and whatever the threshold value you use is used as a decision boundary. Okay. So this we have already discussed, and we were talking about assumptions of logistic regression. First assumption is it logistic regression, the dependent variable, nothing but your y variable in this equation, y is equal to mx or mx plus c. Your y variable can be either binary or multinomial or ordinal. That means it can follow an order. Okay, but it can't be cyclical. If it is cyclical, if it is something that repeats over time, then it becomes time series problem, right? So if you want to, if something repeats one after the other, okay, cyclical, then it can be converted into a time series problem rather than a logistic regression problem. So you can use in all these three different cases logistic regression. Next is observations, means rows should not be repeated. Rows should be independent of each other. No duplicate should be there. And columns should not have correlation with each other. Another assumption is linearity of independent variables. That means all your columns should exhibit linear relationship only. Okay. So this was again one of the interview questions where the interviewer had asked. Okay, I can show you. This is I think this kind of question is trending now. Okay, yeah. So something like this. So the interviewer asked, okay, if you have you have used let's just say scatter plot. Okay, so you have used scatter plot, and when you do a scatter plot, you have a relationship like this between the data points. How will you use linear regression or logistic regression to classify the data points or to use the regression? The relationship is like this. This is quadratic relationship. The answer is you have to do transform. You have to use you have to test with various transformation techniques. Once you convert it into a straight line, only then you can use the linear regression or logistic regression. Without transforming, you can't use. Okay, so this is non-linear relationship. So that's what we are saying. Our assumptions, one of the assumptions is the independent variables are exhibiting linear relationship, nothing but they should be in a straight line. Only then you can use logistic regression or linear regression. And next thing is, so success of logistic regression depends on sample sizes. Sometimes because it is using Hessian metrics and various techniques to arrive at the optimal m value. It requires a large sample size. It needs more and more examples, more and more rows of data to efficiently calculate that m value. Only if it calculates m value, your prediction will be accurate. Okay, that's why logistic regression requires large samples. So that is another assumption. Okay, moving on. So this is what we were talking about. Three different ways you can use logistic regression. Just like how you use linear regression, right? Linear regression you used for polynomial regression, you did Huber regression, you did lasso, ridge, elastinet, various variations of linear regression you used. Just like that, logistic regression can be used for binary, where the target or the y value has two possible outcomes. Okay, for example, spam or not spam, or loan approval or not loan approval. Your resume, even your resume getting rejected by the ATS system is a logistic regression model. They have deployed logistic regression model. Okay, basis on which certain score gets calculated. If the score is above certain threshold, it gets approved. Otherwise, it gets rejected on the spot within 2 seconds. Okay, so this is what they are doing. Logistic regression they have used. So just like that, another variation is multinomial logistic regression. In multinomial, there are three or more categories and they are not in order. Just like what I gave the example, if you are in a school, you want to classify students into certain houses, certain groups, then those groups are not in order. Okay, so that is where you can do it programmatically using logistic regression. Using all you have to do is multi underscore class equals to multinomial. You have to specify that. Rest algorithm will take care of everything. Okay, next is ordinal. Okay, in ordinal means, for example, a student's performance has to be graded. Okay, there you can if you have certain order, for example, poor, average, good and excellent. Okay, their ordinal logistic regression is used. Why? Because these values are in order. Okay, so that you can remember. Next, so using the algorithm itself. So here we have weather of Australian city. We want to predict whether it will rain or not rain. So these are the standard libraries you will anyway use. Okay, and you will import the data using CSV. Okay, read underscore CSV you will use, you will get it. And here in CSV also there are lot of options. I think let me run. I have run, but I don't know why it's not working. Let's run. Okay, so if you use okay, so let's just say you want to infer certain headers in your data file. You had certain headers which you wanted to remove or add. So you have to use this option header. How many lines of data are header, that you have to specify using integer value. If there are no headers, you have to specify it as none. No, but if you are not sure how many are them of our header, then you can use infer. It will automatically try to understand if there are headers. Sometimes it may not infer correctly, then you have to specify integer number and correct it yourself. Okay, so that is one. Delimiter, sometimes you won't have CSV file, you have TSV file. The spacing between the values is not a comma, but rather a tab value. Okay, 4 spaces or 8 spaces. So in that case you have to specify the delimiter, what that delimiter is, or sometimes it is space. Okay, so that way you can use calls is very important. I would say very important parameter. Why? Because if you're working on millions of records or even 1 lakh records, what will happen is you don't want to import everything onto the memory. Okay, you want to use only selected columns for your data analysis or model building. So that is when you have to use calls. Okay, for example, if I specify so here you have so many, right? You have so many columns, but let's just say I want to use only this. I want to know wind speed of 9 a.m. Yeah, so I would use calls is equal to, it has to be a list. I will specify only that. Okay, and let's just say I will add one more, max temp. Okay, I will take this max temp. Let's just say I want only two columns for the sake of simplicity. Okay, if I give like this, okay, now notice from 23 it will go to 2. Okay, now you have only 2 rows of data. See, instead of 23, you now you have only 2. So this way you can select the columns. Okay, and this will help you for data imports, because everything is imported onto RAM. 1 lakh records into 23 columns would be, it would be some amount of memory eaten. Okay, so anyway, so we are importing the data. This is known to you, and we are just checking the column names already known to you. And risk mm is a variable we don't want. Okay, so we are just considering dropping. Okay, you can either drop risk mm is there. No, it's not there. It's not there. So let's not worry about it. It's already not there. Someone has already removed. Anyway, in the original data set, I think they removed. Okay, next, moving on. See, from here your data analysis starts. Up until this point is fine. These are the common steps you will do just to understand the D type, to understand how many values are missing. Okay, so this you will run info and all of this, and you will also run describe just to understand if your data set has any issues, as in if it is exhibiting any outliers and as such. Okay, df.describe you can run, and when you are running describe, you have to specify numeric only. Okay, numeric underscore only is equal to okay, so we'll check what the this thing is. Okay, okay, it's automatically taking numeric, I think. Percentiles none, include, exclude. Okay, they should be numeric only. By default it selects numeric only fields. Okay, okay, if it's returning new by default, then we don't have to worry. Anyway, so it's from this you can immediately understand, okay, what is the max value. You can compare the max value with the 50th percentile. 50th percentile is at 13. If you double 13, more or less you will get 26 or 27, so which is closer to this one. So that means it's somewhat normal. Okay, it's exhibiting normal deviation. So 50th percentile is 13, 75th is 18. Okay, and 25th percentile is at 8. Little skewed, but then again it's skewed on to the right because the minimum value is -6. Okay, so this way you can understand immediately whether what type of distributions exist for all these features. For certain features you can immediately understand. See, the minimum value is 6.8. okay, so, yeah, that is the standard deviation. Okay, not the minimum value. Okay, minimum value is 977, and standard deviation also you can check. If the standard deviation is more than 3, for example this one, see, this is a skewed feature. Immediately you can look at this and understand this is a skewed feature. That means you have to do the transformation for this feature before feeding it to the model. Okay, so that should immediately come to your mind. So look at the standard deviation for this also, too high. This is fine, this is also fine. Okay, 3, somewhere up to 3 or 3 to 4 is fine, but anything above 3 to 4 is skewed. Okay, so that you have to understand just by running this function. Next is we have numeric as well as if you can see object type also are all there, right? For object types you have to convert them into numeric by making use of certain mappings. Now what type of mapping you will use, it depends on you how you want to approach. So here we are just reading all the categorical variables and we are understanding these ones are there. Okay, Now our job, our use case problem is only to predict whether it will rain or not. Okay, so that is what the use case is. So for that we don't want date. Okay, date we don't want, because date is not trainable. Okay, that is another thing. Date is, for a logistic regression, it can't be used for training. It doesn't make sense also, so that's why we are considering dropping this. But next is, you can, rest of the things that you see here can be used, but you have to do the mapping. Location mapping, okay, can be done, because location doesn't have any order. Location doesn't have any order. That's why you will do one hot encoding. Okay, you will separate each location into separate column. Okay, look at the other one, wind gust direction, in which direction the wind is blowing. So this, if you notice, is actually cyclical. Okay, because on a compass all the directions repeat. It's a kind of a cycle. This is also cyclical. Okay, and cyclical. Rain today, rain tomorrow, these are just mapping. You can use one or two. You can use ordinal mapping for this. Okay, so this way you have to understand how you're going to do the mapping for categorical variables. Next is, you have to handle missing values. For missing values, for categoricals, you already know the most occurring value can be taken as a missing value. Or if you want to predict that also, you can use imputers. Okay, K&N imputers and all of that. And for other values, for values where, yeah, for let's just say you want to impute the value of a variable where there is certain order. Okay, for order, I think you can't directly use median or mode. If it has certain order, okay, for that you have to predict. The better option is to use imputers, K&N imputer, K nearest neighbors imputers you can use and impute the values. Next is handling the cardinality. What is cardinality? Cardinality is nothing but the different values a certain column can take. For example, occupation. How many occupations are there in the world? Literally thousands and hundreds of thousands of different occupations are there, and you can't code or map all those things in your training data. So cardinality for such features, okay, has to be handled by bucketing or grouping them. For example, you can group occupation by means of income, maybe. Okay, so in that case, all the high income will be high income occupations will be grouped into one category, medium, then low. That way you can group. Okay, so if your cardinality is high, for example, date has 3416 dates. Anyway, we are ignoring date, leave about date. Location has 26 cardinality. Okay, location, what you can do is you can look at which areas are coming under one particular state. Okay, so that way you can choose and group. Wind direction has 16 labels. Okay, and wind gust direction, wind, I think all these three will be correlated. You can, I think you will get a chance to drop two and you can keep one. So I think, because they are correlated and they are all representing the wind direction. Next is rain today and rain tomorrow. These have only two labels, so you can use 0 and 1. Okay, this way you can decide how to handle the cardinality. Okay, next is you have to handle you have to do the pre-processing of certain features. Especially for date, you can segregate. If you have a date like this, month, year, month, and day, you can separate it out by running this pd.to_data frame. Once you convert it into a date time, by using this you are converting it into a date time. Once you do that, you can pull year, okay, you can pull month, and you can pull date. separately. So this way you can use date, but here we will drop it because we don't need it for logistic regression. Okay, next you have location. After dropping date you have location. Now you have 25 columns because one of the column is split into, day is split into 3, year, month and day. Okay, moving on. So what you will do is, next is you are handling the location part. For location there are 26 locations that you can see, and in for each location how many times it's repeating you are seeing. For example, Darwin is coming 3062 times, so likewise Kobar is 534 times. So locations don't follow any order. Okay, there are two ways you can handle this. One, you can combine them into certain closest regions. Okay, or you can use complete one hot encoding. So this is what the second approach is followed here. So everything is split into separate feature. If you get the location, see, location itself is split into 25 columns. Okay, likewise wind gust direction, it is cyclical in nature, you have to remember that. Okay, now for cyclical in nature you can do one hot encoding. You're splitting it into various, again, separate features. Okay, so you have a lot of values. Okay, anyway, so same thing is done for wind direction. Basically everywhere where there is wind direction, that is split into a lot of columns. Next, rain today has only 2 columns, yes and no. That's why you're gonna only, okay, this also is done as one hot encoding, but if you have only 2 values you can consider 0 as no, 1 as yes. Okay, don't use 1 as no and 0 as yes, 0 yes as 0, because taking into account the values that represent. So no means you can use 0 because it represents nothing. Okay, 1 represents something, so make use of it. Think it that way and use a label encodings. Okay, again moving on. So rain and rain tomorrow are done the same way. Next, you are taking into account all the numerical columns. Up until this point you handled categorical columns. Now you are going to handle the numerical columns. In the numerical columns, okay, first thing you do is you will check the missing values. Now for lucky for us, we don't have missing values. If there were missing values, then you can make use of mean imputation. Okay, just take the mean value and replace the missing values with mean. The next thing is you have to understand the distributions. Okay, distributions, again remember, this is one of the interview questions that even I prefer asking. I have asked this multiple times. Okay, I deliberately try to confuse asking for a categorical variable, how will you do the imputing. So what I do is I pick a categorical variable deliberately. Let's just say I talk about pressure. Okay, in the morning the pressure was this, in the evening the pressure was this, or let's just say wind direction. These are numerical, right? Okay, let's just say I choose this wind direction. In the morning the wind blew in north, in the evening the wind blew in south. Okay, and in the evening the wind blew in west. Okay, now how will you calculate the skewness and how will you transform this feature? Deliberately I ask that because it's a, one thing is it's a categorical variable. For categorical variable you don't need to transform. These are just the numerical values. Transformation is done for numerical columns, not for categorical columns. Only a person who understands these features in and out can answer that question. Although the question is simple, but that is kind of a tricky question. Okay, so this way, not just me, many interviewers try to confuse. Even in easier questions they will they would sound tough. So basically when you are working on numerical features, you will have to handle the missing values as well as their transformations you have to do. Okay, first you have to check the skewness, You have to check what sort of transformation is able to get the values in the normal range Gaussian distribution. So here you can see lot of outliers are there, and outlier treatment also has to be done for linear regression and logistic regression. Okay, so outliers, there are too many outliers, as you can see very clearly tell. This is a box plot, and any value above this upper line is a falls into outlier. Lot of outliers are there. Okay, so for all these outliers you have to make use of IQR range to identify. I mean, box plot by default uses IQR range, but if you want, you can just do the plot, histoplot, okay, and understand the distribution. As you can see, most of the values are concentrated here. It by default is a the distribution is skewed. For all these skewed distributions, you will have to first what we will do is you will get rid of the outliers. How you will get rid of the outliers is by calculating the upper quartile, okay, 75th percentile, multiplying that with 3 standard deviation. The 3 that you see here is 3 standard deviation. Basically anything above the 3 standard deviation is either dropped or capped. Two options. Okay, either you can choose to drop all those outliers. Dropping is not a recommendation, although, okay, just an option. However, capping is, you can cap all those outliers into, you can classify all these outliers into upper limit values. Okay, so that is what capping is. You can directly assign a certain value, okay, like this upper fence, upper values you can assign, and any values that falls outside this range will automatically be assigned the upper value. Okay, so this way you can cap the upper values for outlier treatment. After you do the outlier treatment, you have to transform. Again you have to do the plotting. Okay, we have not done here, but again you have to do the plotting and check how the distributions are looking. The distribution should look something like this. Here the most of the value should be concentrated in the middle. If it is not concentrated, okay, then you have to start transforming. For transforming also, I will show you in the next data set, but for transforming also you have to choose. Okay, there are various transformation techniques. Okay, so transformation has to be done and scaling also has to be done. Yeah, so something like this. Initially if it's looking like this, and log transformation can bring the data in the center. This is exactly what we have to do. Okay, we have to bring the data into the center. So here, as you can see, the data is on the left side. On the left side we have to bring it in the center. You can do the log transformation. Okay, here also I think log transformation will apply for all these 4. This way you have to transform, and there are many other transformation, reciprocal, square, square root. You are free to experiment with whichever works the best. Box Cox transformation is there. Okay, there are many others. Okay, you can, if none of these transformations is coming giving you the required result, then you can invent a new method of your own. Okay, so that also you can combine mean with median, or something like that. You can come up with your own, whichever works best for you. You have to do that. Now transformation, now the next question is, would it not be data tampering if we do the transformation? Would it not be like we are changing the original data itself if it's transformation? The answer is no. What transformation does is it only shifts the mean. Okay, it only changes the structure of the data, but the inherent patterns from the data remain the same. Okay, so I'll give you one example. 1 divided by 5 is same as 20%. Okay, 1 divided by 5 is same as 20%. 20 divided by 100 is same as 20%. Okay, now if you okay, let me write that down. 1 divided by 5 is same as 20 divided by 100. Both are 20% only. Okay. Now changing from 1 divided by 5 to 20 divided by 100 will not change the inherent patterns in the data. Okay, you are just scaling is being changed here. So that is what transformation will do. It will shift the data from left to right, and for it will shift to all the data points. So thereby the actual nature of the data is retained. Hence transformation will not change the original data. Hence you are free to do the transformation. Okay, so that you have to do. After that you can choose what is your x and what is your y. Okay, for your matrix multiplication you can choose what is going to be your x and what is going to be your y. We are trying to predict whether it will rain tomorrow or not, given all the features: wind direction, pressure, temperature, whether it rain today or not. So basis on that we are trying to predict. Now the next thing is, again another mistake made here is always x should come first. Don't get confused. Sometimes you'll write x train, y train, x test, y test. Okay, don't do that. X train has to come first, x test has to come next. Okay, then if you get a doubt, sometimes you might, okay, let me run all. So sometimes you might get doubt, so it is better to check the okay, this I have not. Okay, sometimes you might get the doubt, so what you can do is you can check the documentation. Give me 1 second. Yeah, so here you can go and check the documentation if it is too confusing for you. Okay, so there is one example here. You can copy paste the same thing and proceed if you get a doubt. Okay, so x should come first and then should come y, otherwise all your results will be actually they will be x values will be assigned to y, y will be assigned to x, and you won't be able to do proper modeling. Okay, so once you do this, you have done the x and y splitting. Now ideally you should do the feature engineering before assignment, remember that. Okay, but here they have considered doing it afterwards also, which is fine, but there is a problem. The problem is there is something called data leak problem, which is one of the major issues when you're doing the modeling. To avoid that, what you do is you do the feature engineering first and only then consider assigning the values into x and y. Okay, so here we are using the category encoders, and in category encoders you have lot of methods which can allow you to encode the values by default. Rather than you manually doing it, you can do this thing. Okay, and another recommendation I would say is there is another thing called feature engine. Okay, this is one of the feature engine library. Okay, this one, this has all the possible methods that you could require for doing the feature engineering. My recommendation is to use this feature engine library for missing data, encoding, discretization. Discretization is, by the way, grouping for cardinality. Okay, outlier capping or removal, feature transformation, new feature creations, feature selection, date time features, handling time series. So lot of things are there, and the main folks who have come up with this library are the actual authors of a book for feature engineering and all of that. I remember she it's a lady, and she is very good when it comes to teaching. Anyway, so these are all the methods that are available. As you can see, for category you have a different imputer, for random sample imputer you have, Missing indicator also you can add if a feature, if a value is missing, and you can drop it, arbitrary number input, lot of things are there. Check this out when you get the time. Okay, I will also conduct one separate class for feature engineering, and I will show you how to do various things using feature engine. But for now we will move on. See, this is WE, weight of evidence encoder. This is damn good encoder. Okay, so this takes into account various things. It has advantages over all other encoders, like one hot encoder. People are only aware of one hot encoder, ordinal encoder, etc. But there are many more, as you can see. So all these are different options available in feature engine, and even discretizers, you see a lot of them are there. Okay, outlier capping. So I will teach you what this Winsorizer and all of these things are, okay, in a separate class. But because we are talking about modeling, we will go back to that. Okay, we'll go back to modeling part. So a lot of things are there, so you can do the feature engineering like that. And scaling also, this is also recommended practice, that you do the all your feature engineering and feature scaling before you separate the data. So next thing is scaling. Now in scaling also you have different types. Min max scaler you have standard scaler you have. These are all the various techniques wherein which, see, it's very simple. Why do you need scaling is, see, you have m, you have x, and you have y, right? Let's just say m values you will anyway find out. What if x values are like 1 million, okay, 1 million, and then here it is 70,000. See, to do the matrix multiplication for multiple digits, it is going to take time, right? More time, right? But instead of that, what if you had 0.122, 3.171? Multiplying smaller numbers is much easier than multiplying larger numbers. Okay, so that is why it is better you have everything on the same scale, either 0 and 1 scale, or -1 to 1 scale. Okay, so that's why we need scaling, if to compress everything into 0 to 1 scale. Now again, going back to the same example, 1 divided by 5, 20 divided by 100, both are one and the same. Either you compress or you expand the numbers, their actual data patterns remain the same. Okay, so that's why scaling is done where all the values are numerical in nature. So once you do the scaling part, next, now I would recommend splitting. Just before training you have to do the splitting, and you can proceed with, okay, let's run this. Then you can proceed with the fitting part, model fitting. Now you can call the logistic regression from the linear model. Okay, so here you have linear model. From linear model you have lot of options, and one of the regression is logistic regression. And the linear model is the same option in which you have all your linear regressions also, Huber regression, and there were many others that we went through. So all those are available here. Notice the solver. The most recommended solver by default is added as LBFGS, that is the default solver, but you are free to choose liblinear. Now why are we choosing liblinear is the question. Why? Because you remember yesterday, in yesterday's class we said you choose liblinear when you have lot of columns. Now because we have used one hot encoding, our number of columns have increased, 95 columns. Initially there were 21 columns. Now the number has gone up to 95. So it is a recommendation that you use liblinear when the columns are more. Okay, this is what we learned yesterday as well. That's why we are using solver as liblinear. Rest of the things also you can do. Instead of using penalty L2, I would rather use penalty L1. Okay, why? Because some of the columns, because many columns are talking about wind, and many columns are talking about pressure, they might have certain dependency, some correlation exists there. To nullify the effect of such multicollinear columns, we can use penalty as L1. Okay, L1 is lasso regression. It has the property of decreasing the effect of making the coefficient 0 of certain columns. When m value becomes 0, 0 into x is 0 only. Okay, so the effect of those columns is nullified. Hence I will use this one, penalty, as L1 instead. Okay, I'm refitting the model. Now I have the penalty as L1. The next thing what you can do is you can start predicting. You have fitted the data with X train and Y train. Nothing but you are equating, you are trying to find out m value here. What is meant by fitting? Fitting is nothing but finding m value, and all the things that we discussed yesterday are happening underneath within 2 to 3 seconds. Okay, what all we discussed? We discussed about optimization algorithm. We discussed about how Hessian matrix is being used. We discussed about how the learning rate is being used to subtract the original m value to decrease the m value to actually arrive at the better m value. So all those things are happening just when you do this, call this fitting function. All those things already happened. Okay, now this logreg is a model name that we have given. It stores everything in that. It stores all the coefficients. You can check that also. Okay, so it stores the coefficients. If I call logreg dot coef, okay, coef underscore, see all these coefficients, these are nothing but m values. There are 95 m values for each column. There is a m value, nothing but these are m1, m2, m3, m4 up to m95, because for each x value there exists m value. And notice one more thing, because we used L1 as penalty, some m values became 0. This one. We essentially when we see this, what we can say, this particular column, if you count the number of column, whatever the column name is, this particular column is not adding any impact for our model classification. So it's a feature that can be gotten rid of, as good as not having this column at all. Okay, so this is the effect of L1 regularization. That's why when your columns are high, choose L1, not L2. If you had used L2, this would not have been 0. It would have been very small value, but not 0 definitely. Okay, so this is another thing. These are coefficients, m values. Okay, likewise you also have lot other functions. You can see logreg dot, you have class weights. Okay, class weights, you have classes, you have coefficients. I mean, these I think I can call after I do the prediction part. But anyway, so you can use various other things. Intercept is also there. Intercept means c value. You have only one c. Okay, c value is where the line cuts the y-axis. Remember. Okay, so that c value is at minus 2.33. Sorry, what did I do? Okay, so that is intercept value is also there. Likewise, you have logreg dot scoring part we will do after we predict. Okay, various parameters is there. Solver you can know, because you already know the solver. Okay, warm start also is there. Okay, I mean these things apply for other things. N jobs we can check. That means how many CPU counts did we use, core counts did we use while training. I mean it's not giving any result, but anyway, you ignore that. I think it used all the ones, or not, or maybe one. Anyway, doesn't matter. So this way you can understand your slope values and intercepts. Now after you have done that fitting part, now you have to predict on the new data. New data you already split it into X test. So you are going to do the prediction on the X test and you are going to get the prediction value. So now if you do, now you have obtained the prediction. Now especially for logistic regression, you can do two different things. One, either you can get the class itself. Here you are getting the class no, yes, bolke, whether it is going to rain on certain day or not. For how many rows are you going to get? For the number of rows that were present in X test. If I check X test dot shape for 11,000 rows, you will get this result. Okay, if I check len of this, both should match, len of this. Okay, so both are matching. That means for 11,284 rows you have obtained these results. This is with predict function. But what I was talking about is you can also do predict probability. What is the actual probability the model thought for before, that is before applying the threshold? What is the probability the model thought was for each row? That you can calculate. See, for first row there is 98% probability or 99% probability it is not going to rain. So this is way above 0.5. That's why it's classified as no. Okay, I think there are two probabilities. Sorry, I mean what I said is correct. So it is 98.98 probability that it is not going to rain. Hence it is classified as no, and there is 0. That is 1%. 0.01 is 1% probability that it is going to rain. So these are no values. These are yes values. What you see, two values you are seeing, right? For each row you are seeing two values. This is no probability. This is yes probability. Only when the yes probability increases above 0.5, then you will get the answer as yes here. Okay, so that way, because for all these rows whatever you can see. Okay, let me fetch only maybe 10. Now see, let's see which one has. For all the 10 the probability is no only. Okay, let's fetch 20 maybe randomly. Okay, here, so there is a 94.8% that it is going to rain for whatever the row number is. I think 17 or 16. So for this row the answer would be yes here, somewhere here. If I get what is that, 17. Yes, see, for 17th row it is yes, because this y value probability is yes. Okay, this way predict probability can give you the actual probabilities. Now you can do another thing here. Let me remove this first. Copy and remove. Okay, you can do another thing here. That is, let's just say you are getting too many false positives. Okay, what you can do is you can tweak the threshold. You can increase the threshold for this y prediction. Instead of using y predict results, you can use predict proba and write a custom function saying instead of 0.5 you can set it as 0.6 to reduce the false positives. Okay, so you can tweak that value and then finally get the actual results and assign it to the y prediction value. Okay, that also you can do. I mean that is what you have to do if you want to reduce the false positives. Okay, anyway, so by default it is going to give you all the predictions as well as the all the predictions it's giving and actual class values. So this way you can get the probabilities. Up until this point, have you understood correctly? Any doubts? No doubts means give me a thumbs up, and if you have doubts please unmute yourself and ask me the doubts. Okay, no doubts. It may differ. Okay, this is only for logistic regression. Only logistic regression will give you the predict probability. Okay, I mean there are other models also that give predict probability, but for logistic regression this is how you will do. But if your question is regarding false positives, okay, if it is for false positives, first understand false positives will come only for classification problems. That means problems that are like logistic models that are like logistic regression, decision tree classifier. Okay, basically all the classifiers. So there you can use the values. But again there is a catch. Not many generate the probabilities. If they don't generate, then you can't use threshold. So depends on the algorithm also. As we progress, we will see which algorithms can use this predict probability. For now you understand logistic regression can use this, okay, this methodology. Correct, 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 correct. See, the why, it all depends on the why, as in, okay, the basically what you're trying to predict. If you're trying to predict a number, then it has to be linear regression. And because I have not taught you linear regression, maybe you are having the doubt. I will take separate class for U3, and including Nida, and teach you linear regression, and then you will understand how to decide between linear regression and logistic regression. But for logistic regression, like we said, we have, if we are trying to predict yes or no type of situations, then we have to use logistic regression. For example, spam or not spam. In this case, for this very problem, we are trying to predict whether it will rain or not rain, right? So it's a yes or no type of question. So for that, we have to use the logistic regression. Okay. All right. Any other questions? If you don't have questions, please take breakfast break. I know it's late, but we don't have any other choice. So come back at 10:45, please. We will finish up the evaluation metrics part. There is lot to cover here as well. Okay.